So welcome everyone to the UAV for Payload Deliveries Working Group on Ethics in Drone Design from Academia to Industry. Very pleased that you all joined us today and welcome. So I'm going to start with just a little bit of housekeeping. So first of all, our webinar today is going to be 60 minutes in length, and the webinar will be recorded. The slides and the recording will be available within about a week on updog.org in our resource library, and then it will also be emailed to all of you. And we will have quite a bit of time for a discussion today. So we have two ways that you can contribute to the discussion. If you would like to contribute verbally and to come off mute, you can use the raise hand feature at the bottom of your screen. I will invite you to speak when it's your turn, and a little pop-up will come up that says unmute now. You can just click that unmute button and you'll be able to speak. And then if you would like to contribute non-verbally, you can ask a question using the Q&A feature at the bottom of your screen, and I will repeat selected questions for our presenter for you. And then if you would like to just kind of chat with people or otherwise, you can use the chat button at the bottom of your screen. And if we don't get time for all of the questions today, I will work kind of in the background with our presenter on those, and they will be included in the slides when we share them. So I just want to start by introducing the UAV for Payload Delivery Working Group for those of you that might be on the webinar today who are not members. So UPDWG, which it is called for short, is a global network of over 350 stakeholders who are interested in using drones for help. Our goal is to provide our members with value and to share information, experiences, and expertise to accelerate the integration of drones in health systems throughout the world. And how do we do this? Well, we do this through facilitating knowledge sharing, through webinars like today, newsletters, and our online resource library, through partner coordination and connecting our members for collaborations, through in-person and online networking events, and finally through the creation of the Medical Drone Delivery Database, which is a drones operations repository, which can be found on updog.org. So I'm gonna go ahead and introduce our guest speaker for today, which I'm very excited to have him for this webinar. That's a little bit different from some of our other webinars in the past, so really looking forward to it today. So Dylan Cawthorne is an associate professor in the Unmanned Aerial Systems Center at the University of Southern Denmark in Odense. His research aims to develop ethically informed technology that will benefit society. He's originally educated as a mechanical engineer and worked for 10 years as an aerospace researcher and development engineer for companies including the Danish drone startup Little Smart Things, Boeing, and Scaled Composites, where he helped to develop the Stratolaunch, which is the world's largest aircraft. He then returned to academia, where he to teach and to earn a master's degree in product design and innovation. He now just completed his PhD, where he proposed, developed, and built drones based on values-sensitive design methods and ethical principles, which he will talk about today. So I'm going to go ahead and turn it over to Dylan from here. And please feel free to go ahead and ask your questions throughout the presentation using the Q&A feature, and then we will turn it over for discussion when he is done. So let me just stop sharing my screen here, and I will turn it over to you, Dylan.
Excellent. Thank you. Thanks for having me. I really appreciate it. So we met, what was it, maybe a year ago now in Rwanda?
Yeah, I think exactly a year ago.
Was it? Okay, man. It seems like it seems like a million years ago, a different universe. But yeah, we met at the African Drone Forum in Kigali, Rwanda. And it's been cool keeping in touch and seeing what's going on with UPDWG. And come on, I mean, it's a great name, you know, like what's up, dog? Okay, let me see. Let's see if I can share my screen here with everybody. Gabriella, does that look okay to you?
Looks good.
Looks good. Okay, good. All right. Welcome, everyone. Thanks for joining. Today, I'm going to talk about ethics in drone design. And what I was curious about when Gabriella and I discussed this topic, I thought, okay, well, this is a pretty interesting opportunity for me to sort of get out of my academia bubble and start to engage more with people that are in the industry. So that's kind of the direction that my talk is going to take today. So I'm going to present some ideas that have been developed I would say, primarily in academia, but also I think have a lot of relevance within the drone industry. And then we can sort of discuss on how, do they make sense, and can we take these ideas and then implement them in what we call the real world. So there's quite a lot of narratives going around right now about drones, and are drones going to be a benefit to society, or are they going to lead us into some kind of dark dystopian future? So there's quite a lot of this, I would say, dystopian narrative around drones, especially in Hollywood. And you watch an episode of Black Mirror, and there's a swarm of bees that are, bee drones that are coming and attacking everyone. This video here is it's fictional, but it was created by some researchers in the United States, and it was sort of like a cautionary tale. So they were concerned about the possible implications of very small drones powered by AI, that potentially they could be misused and used to go out and do sort of like strategic murders if people are, protesting against a certain government or a certain institution. So this is one narrative, I guess, like the bad drone, I guess you could call it. And just to give you some, a note that many people that are in the industry probably are aware of, the largest drone manufacturer in the world, DJI, has just been basically blacklisted by the US government, and that's because they've been linked, or at least they've been accused of being linked with human rights abuses, and also facilitating high-tech surveillance and supporting repressive regimes. So there's quite a lot of risks out there with the technology that we're helping to develop. And anytime you talk about how are countries where labor is very expensive, how are they going to compete with, for example, China? Well, they may not be able to compete on price, but they may be able to compete on ethics. And I think this talk will speak to some of those issues.
Hey Dylan, can I interrupt you for just a moment? You have at the top of your screen the little zoom controls. It's showing up as a black bar, so maybe you could just move that off the top. It's just interrupting your titles.
Oh, okay. Is it still visible? And
yeah, it's at the bottom of your screen now, though.
Let's see. I don't know if there's a way to hide it.
Yeah, maybe just move it down a little bit more. At least it'll be off the title of your slides.
Yeah, okay. Sorry about that. Technical difficulty today. I also can't see myself, which is a little bit strange. Do you know how to turn that on by any chance?
No, I don't, unfortunately.
Oh, okay. Yeah. Okay. Well, if something goes horribly wrong with the video, please just tell me.
Will do.
Okay. Thank you. Oh, here we go. Hide floating meeting controls. That sounds pretty good. Excellent. So another narrative that we see out there in the industry is sort of like the good drone. And I've seen on social media, there's a number of drone companies that are using this hashtag drones for good. And I also think this is kind of interesting. So is there such a thing as a good drone or a purely good drone? And is it just what the drone does, or is it also the drone itself? Like, is the drone design somehow implicated in if it's a good drone or not a good drone? I just wanted to give a little bit of context. So as Gabriella mentioned, I'm an associate professor here in Denmark. And my research for the last couple of years has been focused on, are we creating drones that are going to benefit society? And this research came out of my research group, which is about 20 people, working on all different areas of drone development. And we, many of us kind of had this as an aim, that we want to create something that's going to benefit society. But we realized that we didn't know if we were actually doing this and if we were doing it effectively or not. And that's sort of how my research was initiated. I assume everybody here knows what a drone is, so I don't think I'll spend too much time on this. But as you can see, there's a number of different types and sizes and shapes. They could be, a few hundred grams. They could weigh hundreds of kilos. They could be a vertical takeoff, multi-rotor drone, or a fixed-wing drone like a small airplane. They could be a hybrid VTOL, vertical takeoff and landing drone. So there's a lot of different configurations, and I guess that's one of the challenges. When we say drone, we could actually mean a lot of different things. It could mean essentially a full-size aircraft that doesn't have the pilot on, or we could mean something that's this small that that you can buy in the hobby shop. So what I want to do now is I'm going to introduce some concepts from philosophy of technology and make some statements that that have been informed by that literature, and then I'm going to show how those ideas will then influence drone design. So the first thing that I want to mention is that within the philosophy of technology, basically technology is not considered ethically neutral. So technology facilitates us doing stuff, and when we do stuff, those things have ethical implications. So in the US, there's this long discussion about guns killing people or people killing people. And I guess the philosophy of technology literature would say, well, yes, guns kill people, and yes, people kill people. But it's basically a combination of these actors. So you have the human element, and then you have the technology element, the design, the capabilities of it, and then you have all those things placed within some kind of context. So we need to think about the thing that we're designing as engineers, and we also need to consider the context and the use case of the technology. Another thing that we should keep in mind is that technology doesn't just happen. So sometimes you hear this term, oh, technology moves very fast, or it's just going in that direction. But we need to keep in mind that idea is called technological determinism. And we need to keep in mind that that isn't really the case. I mean, people like myself and other engineers have to go to work every day and develop this technology. Otherwise, it doesn't happen. Governments need to fund it. The public needs to support it or at least tolerate it. So it's a lot more complicated than that. So basically, we just need to remember that we are not passengers on this technology train. We are, in fact, driving it. Of course, there are external considerations. There are things like markets and economics that will tend to push things in one direction or another, but it's not a foregone conclusion in what direction technology is going to go. Another thing to consider is that we are working with a technology that is a kind of automation. So there was a study that's been quite highly cited. I believe it's from the United States, and this study said that there was a chance that up to almost 50% of jobs in the United States were at risk of being automated. So that means that within the next 10 years, if I recall correctly, before 2030. So that means that we could face a pretty serious existential crisis. So we've kind of seen that with COVID. All of a sudden, many people haven't been able to go to work, and that has pretty serious economic as well as psychological impacts. So I think what we need to do is consider, do we really need to automate everything, or do we need to design for meaningful human work? Do we need to sort of like emphasize the meaningful parts of the workforce where human beings will take part, and then the less interesting stuff we could automate? Another thing that we hear a lot in the drone industry is people calling drones a platform. And there's a very nice paper written back in 2010 called The Politics of Platforms. And this was discussing YouTube, and now we could also talk about Facebook and other social medias. And they also like to refer to themselves as platforms. So what they mean is that they are sort of a neutral meeting place where people can exchange, information. And essentially what they're saying is that they're not responsible for what happens on those platforms. And I think that we in the drone industry are doing the same. So we're saying, hey, we'll give you a flying thing, and you can do with it as you please, and you can put all kinds of stuff on it, and the rest is sort of not our responsibility. And I think that this is, I don't think this is the most responsible way to develop technology or a very responsible narrative around it. Another issue that we're always going to be confronted with in the drone industry is that of dual use technology. And the term dual use has two main meanings, civil versus military and good versus bad. And in both cases, I think that there's quite a lot of gray area between the two. So for example, surveillance tasks, border control, security and control, these kind of things are somewhere in between civil and military. arguably, and also between good and bad. I mean, whose definition of good and whose definition of bad. But the main point I want to make here is that oftentimes the same technology is being used in both contexts, or very similar technology. There's a very nice paper written by, book chapter written by Amy Van Weinsberg called "Civilizing Drones by Design," and in that chapter, she discusses why there should be inherent differences between a military drone and a non-military drone. So what do we do about all this? Well, that was kind of what my research was all about, and I found a number of different directions to go. I think the most useful was this approach of what's called value-sensitive design. Value-sensitive design consists of three main phases. The first phase is a conceptual phase, and this is where you look into things such as human values. What are the human values that are at stake with a certain technology? You also take into consideration which stakeholders are going to be impacted. So this is not just direct stakeholders, so people that are paying for it or people that are operating it, but also indirect stakeholders like the general public or people that just happen to be nearby during an operation. The second phase is an empirical phase, so empirical analysis. This is the kind of thing, this is the part where we see the technology and the human society interacting. And we can do a lot of social scientists, for example, can be very useful in this empirical phase to see what is the interaction between the technology when we actually implement it. Do people react positively to drones being around them? Do they react negatively? What level of trust do they have? These kind of things. And the third phase is what us engineers are most interested in, and that's the technological phase. So basically what we do is we take the inputs from the conceptual and empirical phases, and then we try to wrap those into the technology and make technology that embodies and supports the human values that we find most important. And the conceptual phase is an area where ethicists and philosophers probably have the most to say. The second phase, the empirical, is probably where the social scientists come in, and then finally the engineers in the technological phase. So if you're an engineer, like me, a couple of years ago, when you said human values to me, I didn't really know what some examples were. So here's a few. We might think about things such as human welfare, so physical and psychological well-being, bodily welfare, things like health. There's a lot of people here working with healthcare. Things about privacy. So drones are, of course, a very big potential threat to privacy. There's even something called the chilling effect, which happens when people feel like they could be watched at any moment. And of course, that could, in a worst case scenario, that could be the case with drones, with cameras flying everywhere. We also think about things such as human autonomy, so the ability to decide for yourself and make decisions on your own. Also, issues such as informed consent. So are the drones operating around people? Have people given their permission to have that operation near them? Or is their consent assumed? And is that fair? And then there's some other human values that are important. So things like calmness, peace and quiet. Maybe you don't want drones buzzing around you all the time. Maybe you don't want drones flying past you in your visual line of sight. And then finally, issues such as environmental sustainability. So are drones going to have a positive impact on the environment, or are they going to become a piece of electronic waste in the end? These are all, important human values that we can consider. So my research has taken a number of different directions. One of them was creating an ethical framework, and this was specifically for the context of drones within public health care, primarily in Western countries such as the United States, Canada, and Denmark, other European countries that have universal healthcare. And you can see that it has a number of different levels. At the top level, we have these ethical principles, and then at the second level, we have human values, and then the final level, which is below this one, is not shown because it's very complicated, but that's where we look at the design requirements of the drone. So how do we make a drone that then supports these different values that we've identified? And most of my research has been around the Danish healthcare context, but I also wrote a short paper, sorry, 2 papers about a humanitarian cargo drone in Peru operated by We Robotics. So this is the drone that I developed as a prototype, and the idea for it was to try to see what is it like to actually implement these ethically informed design approach to create a piece of technology. And this is the drone that I came up with. I think if you can see on the camera, it's this one right here behind me. And what I found was that it gave some kind of unique features, and that it sort of helped me or caused me to reframe what it was that I found important when it came to drone design. I'm trying to remember. Yeah. So I'll just mention a couple of the interesting features. Probably the most important thing is the size and the shape of the drone. So a pretty fundamental question that we need to ask ourselves is you know, what is the purpose of the drone, and how much does it really need to carry? You know, so this one was for blood sample transportation from the islands in the southern part of Denmark up to the bigger hospitals, maybe about 25 kilometers away. And that really informed the overall configuration of the drone. So I knew that I wanted to minimize the size of the drone so that the inherent safety was very, very high. This one weighs about 1 kilo. I wanted to actually minimize the cargo capacity because I only wanted to be able to carry 2 blood samples. And you can see that there's other safety features. So for example, the pusher propeller and the foam front end of the drone. But most importantly, I realized that it was really a matter of prioritization on how important is the capabilities of the drone compared to how important is the safety, security, privacy, and some of these other things of the public and the people that are going to be exposed to the drone. So here you can see that I've made a lot of design decisions that tend to push the features to be quite minimal. Therefore, the impact to the public being quite minimal, as well the capability. So the ability to carry large stuff, for example, is also minimized. And I think that's an interesting discussion that we can maybe have at the end of the presentation. Another thing you'll notice is that it's very brightly colored. So in Denmark, this is how our ambulances look. They have this yellow and green color. So we wanted to make the drone what we call explicable. So easy to understand. If you see it, you know what it's doing. So here we've painted it in this way. Also marking it with things like biohazard marking, writing in Danish that it has blood samples inside, and also identifying that it has a camera on it on the tail for navigation. So during this research, I found that there was quite a lot of risks that came along with increased capabilities of drones. So myself and my master's student wrote a paper called Capability Caution in UAV Design. And capability caution means that we need to set reasonable limits to the technology's capabilities during the design phase. For one, that reduces the risk of misuse, and also it increases the safety and reduces cost, as a number of additional add-on benefits. Give you a few examples. One of them was we wanted to give the drone pilot something interesting to do, and we wanted to make sure that we were utilizing their human skills. So we actually made the drone piloted through an FPV camera, a first-person view camera. But then we were also concerned about the privacy risks that go along with having a camera on the drone. So what we developed is a privacy-preserving camera system. And I have some students now that are helping me develop this system even further. But right now it's quite simple. So what we do is we just reduce the resolution of the camera as we get very, very close to the ground. So when you're handling the drone or when the drone is not flying forward, it will actually turn off the camera. And then once the drone is in flight, it will have a low resolution that will still allow you to pilot the drone perfectly fine. And then once you get up to a higher altitude, the resolution increases. And this is quite a lightweight and simple approach to a privacy preserving camera system. So of course there's like active blurring of people's faces and active blurring of license plates and other things like this that are available, but those systems are quite large. So we wanted to make something lightweight. Another example, of course, this is just a prototype and it's not so pretty, but the idea here is capability caution on what the drone can carry. So you see so many cargo drones. I mean, they just have these huge, beautiful cargo bays that you could put all kinds of nefarious stuff into. And what we wanted to do here was try to at least reduce the likelihood that people could misuse the drone to carry other stuff. So we have an RFID system. It's quite lightweight, and the RFID system will give you permission to open the cargo hatch, and then we have these small tamper-proof RFID labels that we stick onto the medical samples. And so during startup, the drone will scan through these RFIDs tags and make sure that the approved cargo is on board and nothing else. And in connection with that, we made a number of capability caution design principles. So one of them is about the context of use. Gabriella and I were discussing that yesterday. So of course, there's economic incentive to create just one drone and then use it all over the world. But what we find is that this can be quite problematic. So we need to consider the context of use when we're designing a piece of technology. We also need to think about privacy, jobs and human skills, safety, security, and misuse. And then maybe the most abstract one is thinking about the future. So as we begin to automate the healthcare sector, for example, what are the implications of that? In the project that I was working on, it's we see a movement from a number of small clinics across the country to these super hospitals. And I see that these cargo drones will facilitate the movement to these super hospitals. You know, then you can just take the samples at a very small clinic and then send them to the big hospital. But there's pluses and minuses to this. You know, people won't be able to go in physically. They will just go to a doctor. They will just go into the clinic. So yeah, there's a lot of implications for this in the future. And just to give an example of comparing sort of what I would call the standard high-tech, very beautiful VTOL drone and something like the drone that I developed, you can see that they're quite different and that they've prioritized things differently. You know, the wingcopter, for example, is a beautiful piece of technology and really, really cool looking and amazing how fast and far it can fly. But of course, it also has with it a lot of risks. It's quite expensive. You know, it's a little bit hard to see who's behind it. You know, it doesn't have this. Of course, it could be painted to give more explicability. And you know, it's also highly automated, so there's maybe a bigger risk of losing jobs while utilizing that drone. So I hope this gives you some example of kind of the difference of prioritization of values. And as I mentioned, yeah, this issue of explicability is pretty important. So explicability just means making it obvious what the technology is doing and who's in charge of it. And we have this built-in problem with drones because, of course, they're wireless, so we don't know necessarily who the pilot is. And we've done some empirical work here in Denmark where we found that people automatically, when they see a drone, they look around for the pilot. So they're trying to figure out who's behind it. And if the drone is flown from hundreds of kilometers away or thousands of kilometers away, they're never going to be able to see that pilot. And yeah, it might also not be a pilot behind it. It might be flying autonomously. So we need to be able to convey that information from the drone to the person on the ground. Maybe that ends up being an app, but it also should be the color and markings and perhaps lights. Yeah, other distinguishing characteristics that we can utilize. We did some flight testing of the drone. I think I'll just play, just a very short clip of that. So you can see I think this was maybe the second flight, so it's still a bit scary. Okay, ready, Raf?
Yeah.
Okay.
Go.
And I think you get the idea. Yeah, it still needs to be fine-tuned, I would say, but it does work. Another thing that you might have noticed is that it has this kind of interesting sound profile. And that's because I wanted to try and lower the sound frequency so that it's not as annoying. And there's been empirical evidence showing that the lower sound frequencies are less annoying to people. So what I did was I made a gear drive and then used a very large, slower turning propeller, which shifts the sound frequencies down into the lower frequency ranges. Yeah, and there's basically tons and tons and tons more to do. I think there's a lot of interesting stuff that we can look at as far as explicability. So making the drone more easy to understand who's behind it and what it's doing. Maybe it should be an app like we have down here in the bottom right of the screen, showing where who the pilot is and where they are. And this could be accessible to the general public. Also, perhaps we need to think about a different approach to automation. What level of autonomy does the drone possess? And perhaps maybe the pilot should be more in charge. Humans are really good at making decisions and route planning and avoiding obstacles and all this kind of stuff. So we need to keep in mind that they might be a good option as well. Yeah, so I appreciate that we're all working within a market economy. And I think that this is one of the challenges with working with sort of like ethically informed technology design. So there hasn't been so many studies, but there's been at least one that showed that there is an increasing cost, at least upfront, when you do this value sensitive design approach. And yeah, so I mean, there's just going to be conflicts between market forces and perhaps human values. And I really like this quote by Max Neef, and it says, "The purpose of the economy is to serve the people and not the people to serve the economy." So I think when we find situations where we can't do the right thing, or it costs more to do the right thing, then we need to make some kind of adjustments to the economic system or to the rules that surround the operation. I just wanted to give an example of how ethically informed design can be a competitive advantage. So there was some years ago, the United States government was looking for body scanners and for airport screening. And there was a number of companies that submitted designs, and they went for very, very high-tech, high-resolution scanning. And you can see essentially like the person is being stripped naked. And another company came at it in a different way. So they realized that preserving people's privacy and dignity was nice, both for the person being scanned, also for the person doing the scanning. Maybe if you work at the airport, you don't want to sit and watch naked people all day. So they came up with a different concept, and that was what they realized was you don't really need a perfect scan of the person's body. You just need to know if there's some kind of metal or object on them. And so they came up with this different design, which the government was quite happy with and purchased. And yeah, another quote from a colleague that did a talk a while back at a teaching and learning conference that I really liked. He says, "Technology without ethics allows us to do stupid things in a very clever way." And sometimes I think that that's what we're doing. We just find technology so interesting and so exciting, but we need to ask ourselves, is it really going to make the world a better place? Let's see, and this final part of the presentation, I have a number of different recommendations. I think I'll go through them pretty quick though, because I have quite a few slides, and then we can just get into the discussion, which I think will be the interesting part. Yeah, this is just more about contextual design. So, one drone to rule them all, or do we make a couple of different more contextually aware designs? Perhaps like we need a North American drone and an African drone and a European drone. That might be one way to go about it. Yeah, I also want to discuss that there are some standards out there, ethically informed design standards and certification programs that are in work. The IEEE P7000 standard has just been released. It's in a draft form, and that's the process for addressing ethical concerns during system design. And I noticed that it has some elements of value-sensitive design, so that's awesome. That's a great step in the right direction. IEEE also has an ethics certification program. My friend Amy from the Netherlands, co-founder of the Foundation for Responsible Robotics, is in the process of developing an ethical quality mark. She said it's sort of like fair trade coffee, but it's fair trade ethical robots instead. And we also have the ability to self-regulate. So those of us within the industry, we can, such as they've done in AI, we could develop a trust label, or we could self-regulate by introducing things like capability caution or privacy by design. So another risk once you go down this path is ethics washing, and this is something that I'm always nervous about, and I haven't seen any or experienced any sort of like gross situations where I felt like there was an ethics washing going on. But as soon as you have an ethics person in the project, then of course there's sort of like an association that then the project will be more good, and therefore, you know, like maybe you don't have to listen to the ethics person, but they're just on the team, so being ignored. So this is another risk when you even go down the value sensitive design path. Yeah, I think this is getting towards the end, and I wanted to discuss the idea of responsibility. So I think that us as individual engineers should take an increased amount of responsibility for the technology that we develop, especially once you accept or realize or believe that technology has ethical implications. So as soon as that becomes the case, then you are ethically responsible for the stuff that you create. And I think also companies could be first movers here, or could support this by self-regulating. Otherwise, they're going to end up in a race to the bottom. Who can make the cheapest, sketchiest thing and sell the most of it? And I think governments and policymakers also need to reward responsible practices and restrict the irresponsible ones. So perhaps there's some laws that need to exist. We've already seen this as far as privacy goes in the drone area. Also, the dual use technology being export and import restricted within, for example, the European Union. And finally, the public should also be actively involved in the process of technology development. Perhaps they're not developing the technology themselves, but they're giving input to it. And this is an important aspect of value-sensitive design, is taking into consideration the inputs from various stakeholders. And finally, I just want to mention, we always have the choice to not build something. I think that there's all kinds of things out there that we could build and that we shouldn't. So yeah, let's always keep that in mind. Do we really want to go down this path? Yes. Finally, I just want to thank all my collaborators. So I haven't done this work alone. There's been a lot of people, amazing people involved. Amy in the Netherlands, Alessandra, Mariana, Arnie, and of course, thanks to the Danish taxpayers for funding my research. Yeah. And for those of you that are very interested in reading academic research, you're certainly welcome to. I've written a bunch of papers these days, so please check them out. And Gabriella, I think that's it.
Great, thank you so much. I'm really, really happy that you were able to come and present today. I was so captured by your work because I think for so many of us on the phone here, since we are interested in using drones in the healthcare sector, our work inherently is about ethics as well too. And sometimes it's something that isn't always at the forefront of our minds in what we do, or maybe we think about ethics when it comes to community perceptions of drone technology, but how to actually think about that in a little bit of a deeper sense of not only the implementations of our work, but the actual technology itself was such an interesting new concept for me personally, and something that I think is really important to share and to think about throughout our community. So I'm really, really happy that you were able to present today, and thank you. So I'll turn it over to the discussion now. So again, if you have any questions or comments, you can either click the raise hand feature feature at the bottom of your screen, and I will unmute you, or you can go ahead and ask them through the chat function or the Q&A function. So I see one from Hansen now. Hansen, do you want to come off mute, or would you like me to read your question? If you'd like to come off mute, you can go ahead and just say yes in the chat, but if not, I will go ahead and read your question. I'm struggling here. I'll do it for you. 1 second. I'll allow you to talk. There you go. You should be able to unmute yourself now. Oh.
Well, thank you. Yes. Can you hear me?
Yes.
Excellent. Thank you. Yeah. Yeah. I wondered how you managed to shut everybody down. But yeah, thanks, Dylan. That was great. I was actually at the same place in Kigali. I missed you, but great that we can meet here as well. And anyway, Dylan, I was just curious about this empirical aspect of the value-sensitive design, where, you know, as you say, roughly the idea is to get an idea about what values are at stake with any given design. And I guess, you know, if you look at sort of a comparable case, which at least changes the scenery and our infrastructure, wind power, it can be quite hard to get people to sort of, in a meaningful way, vocalize their concerns. And sometimes that's just brushed aside and as sort of, you know, NIMBYism, and, you know, we don't want it here, and we're just being selfish. But lots of research now points to suggest that, you know, there are actually deeper concerns, but they can be quite hard to voice. So I'm just curious. I mean, did you encounter any kind of misgivings expressible as values, and were you always able to? You presented this kind of categorization of values. Could you always, as I say, slot it into one of them?
Sure. So I think the first part of your question is talking about sort of like value elicitation. How do you get how do you extract values from people? And I think what's different about VSD is that you sort of need to go. There's different tools, basically. So instead of what I would say is in some ways kind of like more superficial stuff, you know, like how should the thing work and this kind of stuff, you know, you need to dig deeper into like what are the existential risks or misgivings or whatever, which is pretty hard to get at. One thing that we did a while back was we did a focus group, and we did this focus group with like 7 or 8 people, and these were people that self-reported as being technology optimists. On a scale of 1 to 10, they rated themselves 7, 8, 9, something like this. So they were in for technology. The interesting thing was once we started talking with them, a lot of their fears came out. I mean, and they were significant fears. One of them at one point said, you know, oh, if a drone was around me, I'd shoot it down. And people were saying things like, oh, technology just goes forward and we have no control over it, and, you know, we can't keep up. So I think part of it is just, you know, engaging them in a process that gives them enough time to think through the issues and to consider, you know, what the implications might be on them and their children. Like what are the future implications? See, the second part of your question, could you repeat it, please?
No, well, I think you pretty much answered it. It was really just if it is a matter of values, whether you experienced it being difficult to put their expressions into. You had a categorization of values, right? So you always, you know, should always ask where did that come from, and did it work in your case?
Yeah, I mean, of course, there's like this idea of should we come with predetermined values, or should we sort of just ask people and see what they come up with. So we did some coding of the data. So looking at the type of words that people used and trying to categorize it. And there was some, I don't remember the details of the data, but that would be one way to get more of what I would call a bottom-up input as far as categories of things that people are concerned about. So like there's a colleague called Ning Wang, and she's doing, for example, research in Nepal, and she did this very bottom-up approach. She went and hung out with the people that are, sort of like being exposed to drones, and tried to figure out how is it impacting their lives. So I think this is another way to go about it. But the categorization is quite useful in the beginning if you don't really know what you're looking for. You kind of need to start somewhere. So I think a combination of top down, bottom up, abductive processes makes good sense in this case.
Ning is actually with us today, so I might put Ning on the spot and allow you to talk, Ning, if that's okay, and have you comment on that.
Oh, she's on mute. You're on mute, Ning. We're getting the Kigali squad back together.
Ning, you should have just gotten a pop-up that allows you to unmute yourself. But that's okay. You might be away from the keyboard. So so I'll put you on pause for a moment, Ning, and then if anybody else, or Hansen, do you have any other follow-up for that?
I do, but I think others should have a chance. Really, I can go on.
Yes, if anybody else has any questions, please go ahead and use the raise hand feature or add them to the chat. And I will go ahead and unmute you. And I see Marco. Marco, you should be able to unmute yourself now. Great.
Give that a try. Is that working now?
It is.
Yeah.
Good day. Thank you very much for the presentation. Very informative. I do work with one of the official regulators in North America, on the northern side anyways. And I do find the topic very intriguing. A lot of regulators are using kind of the risk-based approach, and they're looking at risk from both the operational and the product or aircraft risks, right? Primarily through some sort of SORA approach. Now that operational risk assessment, by the regulators, when the regulators are looking at it, there is a tendency, I think, to informally do a kind of a values check in terms of what is the public interest. How do we rationalize the extent of our involvement, or how much we interrogate the product and the actual operation. But how do you think a regulator can regulate that without being, the overlord of all things drone?
Yes, that's a good question. I think it's a tough one. What we see, at least empirically, is that it really matters to people what the drone is doing. So I think something having to do with what is the purpose of the drone makes good sense. So I mean, different categorizations of, delivering, coffee might be in a different category than, for example, emergency delivery of medical supplies or something like that. I mean, to me, that makes good sense. And I think most people in the industry and also in the public would tend to support something like that. I also, you mentioned the SORA, and of course, I think it's quite important that we have some guidelines as far as the physical safety risks of drones. But I think that the industry is, we as engineers tend to focus, I think, in some ways too heavily on safety. Actually, privacy is considered a bigger risk in many studies. So, and these existential risks, like what happens when there aren't so many jobs anymore. These are the ones that are a little bit, I would say, more in many ways more important than just the physical harm. Also, I think there would be an interesting discussion about what is the quantitative metric of what is the level of risk that we're willing to accept, and should we take this number from commercial aviation. I mean, isn't it a completely, not completely, but isn't it a substantially different scenario that we're looking at? You know, for example, you actively accept risk when you get onto an aircraft. Whereas if you're walking down the street and a drone falls down and hits you in the head, you didn't sign up for that. So I think that, yeah, there's a lot of different directions to go, and a lot of work that we could do that would make things better. And I think this perspective is quite useful because it does kind of get you out of this normal, like, you know, operational mindset, but then thinking about sort of the bigger picture.
Thank you. Definitely giving me things to think about, so I appreciate it.
You're welcome. Thanks, Marco.
And we have one comment from Mike, who is a professor of UAS technology, and he's going to be teaching a management class that has a chapter dedicated to UAS and ethics. And he's just asking your permission to quote you during the talk, which is great.
Sure. I hope I did say anything today.
And then we have another question from David, and then I'll turn it over to you, Hansen, if we don't have any more. Question around how to balance privacy versus security in the surveillance application specifically. Struggling with the argument when both values are the same as are they as important in that context in the surveillance application?
What I would say is that I don't think these things necessarily have to be mutually exclusive. So there's a very nice, if you're interested in privacy, then I recommend that you look into this privacy by design literature. I believe it's a paper from 2012 written by researchers in Canada. And it's a really nice guidelines. And basically they say, you know, you don't necessarily have to sacrifice privacy for security or vice versa. And I think that's the most important comment on that.
And then one question from Tendai. If human error is a significant cause of accidents, does it not help society to have automation? Or what are your kind of thoughts on that?
Yeah, I think that's, I think that is partially an empirical question. So we could do some experiments and see, you know, at what point do humans get better, or at what point do the autonomous systems get better at making decisions than humans? That would be an interesting piece of data. We also need to keep in mind that there is a difference between human decision making and automated decision making, and you're seeing this, excuse me, in the within the self-driving car discussion. So anytime a Tesla crashes when it's on, you know, autopilot mode, then everyone freaks out, and you know, is that a justified freaking out or not? I mean, when people make a mistake or fall asleep or don't pay attention at the wheel, then we know that we're used to that. That's human error. But when it's an autonomous system, then we don't know who to point the finger at. So there's this nice literature about meaningful human control of autonomous systems, and I would suggest that you look into that. We should do something similar within the drone industry, I believe. So basically make a system where you can always find out who's accountable and who's in charge of the operation. So I think the way that we design drone autonomy now is a little bit sketchy because, you know, especially if it's flying autonomously and you're a safety pilot, that means that you're just sitting there being bored, you know, watching the screen, and, you know, it's the same as the Tesla. You're just sitting there and it's super boring, and, you know, you're not really going to be ready, excuse me, if something goes wrong. So I think the system design could be improved significantly.
Thanks for that. Hansen, I'll turn it back over to you for your second question.
Okay, thank you. Yeah, no rest for you, Dylan. I'll just a slightly sort of pessimistic note. I don't hope this is the last note today, but yeah, my question is, so you define yourself sort of against you mentioned the platform description of drones, and you mentioned Gillespie's quite influential paper from 2010, and I guess one of the reasons why we now have a platform economy is because, you know, platforms can present themselves in one way to regulators, in another way to certain businesses, and in a third and fourth way to different kind of users. and so forth and so forth. And until recently, actually successfully do this kind of both marketing but also rhetorical strategy. That's probably why they make so much money, right? Your talk is called, what is your talk called? Getting VSD out of academia into your industry. That's the gist of it. And you kind of seem to go against, with your capability caution, to go against the kind of neutral platform design, as it were, or sort of design principle. So I guess my pessimism is this, that you're deviating from what has proven immensely successful in the market. I'm in contact with Bostak, who's written about VSD and now is working with privacy in one of the big platforms, and he doesn't hold much promise for VSD in industry. What do you make of these, let's just call them sort of economic forces that you're up against?
Yeah, I think it's going to be tough. I think I would tend to agree with him. I don't know. That's not maybe the most optimistic answer, but yeah, I mean, well, I think you could look back in history and see a number of situations where people or industries were able to take advantage of a regulatory or moral gap. You know, like, well, I'm from Alaska, and there's certain areas in Alaska that are still seen that were clear cut back before, you know, forestry was regulated. And there's people that made a lot of money off of that. So yeah, I think he's probably right. If things keep going the way that they are, then yeah, there will be opportunities to make a lot of money. And arguably the same could be said about the drone industry. So we're monetizing airspace, taking something that's sort of free and accessible to everyone, and we just sort of take it for granted that there's not all kinds of stuff in it that's interfering with our lives. And then we're, passing through it, collecting data. So yeah, I think it's, I don't know the answer. I think you're right. I think he's right though.
I might jump in there and ask kind of a nice leaving off question related to that. So if you mentioned in your talk that you do think this will inherently increase the costs of design and potentially because it might take a longer time, it's resource intensive. Do you have any suggestions for maybe the drone designers out there right now of light touch ways and that they can start, or maybe some quick, easy wins that they might be able to implement today, or tomorrow, or the next time they're looking into their design?
Somebody vacuuming it there?
It's a coffee grinder, sorry.
Is it still yeah, that's a good question. I mean, so yeah, there's been a little bit of work that shows that the cost might go up, at least initially. However, there is an argument that perhaps in the long term, it will be less expensive because, for example, you don't have as much pushback from regulators, you don't have as much pushback from the public. So, I mean, there's a possibility that you do more work up front and then things become easier later on. That's one possibility. I think that there's a number of fairly straightforward things. I mean, like explicability, for example, get out some paint the thing, label it. If you don't need a camera on it, take the camera off. If you, put a little bit of security measures on your cargo bay. Yeah, I mean, I think some of these things are fairly straightforward. Maybe think about using different propeller design so that the frequency is the sound frequency isn't as annoying. There is definitely stuff that's a heck of a lot easier than some of the other stuff. Let's just say that. Yeah. But what I try to do in a number of those papers was to make it practical, to give practical advice. So, in the explicability paper, we have a couple of design prompts that designers can take into consideration. In the capability caution one, we also have these different design prompts. So yeah, just look through a couple of those papers, whichever one interests you the most, and I think you'll get some advice on and some examples as well on to how to implement some of these straightforward things.
Great, thanks. And we are just about out of time, but we have one request to send links to the papers, which definitely they will also be in the presentation when I send it around. And then maybe you could pull that privacy paper that you just mentioned. And we just have a couple of lasting comments from some of our drone designers here around their work. So thank you, everybody. If there's some last questions in there, I'll make sure to follow up with Dylan when we're done. But really wonderful to have you today, Dylan, and thanks for all of the really interesting discussion. And if you're interested in contacting Dylan to talk more, you can reach out to info@updog.org, and I will go ahead and put you in contact, or I'm sure you can find him online as well too. So thank you, everybody, and have a great rest of your day.
Thanks, Gabriella. Bye, everyone.
Bye, everyone. Thank you.
Thank you. Bye.